Okay, so in this example with hypothesis testing about a mean with two independent samples, we're now going to do the one with given raw data. And so we're going to discuss the state and traditional quarters. I know how much you love those quarter problems. Okay, so a researcher wanted to know whether state quarters had a weight that is more than traditional quarters. The researcher randomly selects 18 state quarters and 16 traditional quarters, weighed each of them, and obtained the following data. Test the claim that state quarters have a mean weight that is more than traditional quarters at the zero point 0.01 level of significance. Okay, so we want to test the claim that state quarters have a mean weight that is more than traditional. And so this would imply that sample 1, right? So we could do mu sub s and mu sub t for traditional. And the state quarters mean weight is more than, right, traditional. So we can kind of already see what our alternative or claim will be. Okay, so the nice thing about this one is that a normal probability plot and of state quarters indicate the population could be normal and no outliers. So what's good about this is that they're giving us the fact that it's a normal probability plot, indicates that the population could be normal, and so therefore we don't really need to do any extra, because anytime we were given raw data in which samples were less than 30, we had to do those normal probability plots and the box plots, right? So again, the preliminaries always have to be met no matter what. So preliminary. So here, the first thing was always that the sample size n sub s for state quarters is equal to 18, which had to be no more than 5% of all state quarters, right? The population. Well, I'm pretty sure 18 quarters is a lot less than how many quarters are out there. And then the second sample, the traditional quarters, which there were 16 of them, there had to be no more than 5% of all traditional quarters. And so that's met, right? And because this is a little different than normal, right? This part 1 is always about taking independent samples. But since these samples are so small, they are likely to be independent, right? So the second criteria is that the sample size for both have to be more than or greater than or equal to 30. But that is not the case, right? Because they're both less than 30. However, it's given that the box plot had no outliers and the normal probability plot showed a pattern. And so we are able to say that given approximately normal population. And so we want to go ahead and give you this information now. I think chapter 1 is the best time to actually really dig deep and do these type of tests. But I think like once we get in chapter 10 and 11 and 12 and 13, like I think we can give you that they're normal, and then at least you had now in the future for your research methods class have technique for the time when these sample sizes are less than 30 when you're testing about a mean. Okay, so now that these are met, we can go ahead and now do the hypothesis test. So let me go here. Okay, so the first thing we always do is identify the scenario. They give us the mean weight of the quarters, and therefore we know that we're testing about a mean. The second scenario, the second part of the scenario is how many samples. So notice they give us state traditional, 2 samples. and therefore we're going to use a 2-sample t-test. So the first step is let's go ahead and set up the hypothesis. So recall the hypothesis is status quo. So again, we're comparing two means of two different quarters. So that's just equal to. But as we noticed before, that the alternative is the fact that we're testing that the mean weight is more than traditional. And therefore, it's going to be a greater than, it's going to be a right-tailed, and then mark your claim. So the second part is drawing the curve. And so this is going to be a right-tailed test. And recall step 3 is alpha. And luckily they gave us alpha 0.01. And so we know that this is going to be 0.01. And the fourth part would be putting this data in a list and running our 2-sample t-test, right? So let's go ahead and put these in a list. And so recall that the traditional quarters is 16, and the number of quarters for state is 18. So those look pretty good. So now what we're going to do, if we go back to our, I'm just going to move this up a little. Okay. And so step 4 now is the calculator work. We're going to go ahead and use the p-value approach. And you're going to have to do a 2-samp t-test. But then you're going to select data. And it's very important when you select your data that you understand that list 1 is my state quarters and list 2 is my traditional quarters. And the reason why I'm saying this is because recall your claim or alternative hypothesis depends on that. If you put traditional in list 1 and state in list 2, that changes your inequality. So just be consistent. Like if state quarters are on the left, make sure your state is in the left list, like list 1. Whatever list is to the left of the second list. Like just be consistent because that will minimize your error. I mean, sometimes students get these small errors and they don't know what they're doing wrong. And really all it is the switch of lists. So, we're pretty much there. So all we have to do now is just go back to the calculator and hit stat and hit test and go to 2-samp t-test, which is number 4. And now we're not going to give given stats. We're actually going to put our data in, right? So hit highlight data, hit enter. And my list 1 is state. List 2 is traditional. That's consistent. Leave those frequencies the same. Pick the correct tail test. Mine was right-tailed, so that looks good. Pooled, no. And calculate. So here, let me drag this menu over. And I want to show that when you do step 2 and you draw, it actually has a draw in the menu. And if you hit enter, and you can see that it's going to draw that normal curve and shade that little area piece to the right. And so, and it tells you like the p-value. So let me drag this over. So if you hit draw, what you could do is have it just drawn on the calculator to give you a good idea of what it would look like rather than my hand drawing. You could go ahead and just do it in the calculator. So number 2 is really just a visual. And so notice that it gives us the p-value. Now, of course, you can always go back to the calculator and do the stat and the test in the 2-samp t-test um, and do calculate, and it gives you that full menu, right? So let's go ahead and go back. So see how it gives us that whole menu once again. So it's up to you. I think if the p-value is not close to 0, and it will show on the graph, I think you could do just the curve and the drawing all at once. Because all we need is that p-value. Let me highlight that p-value. And then here's the p-value here. So the p-value is equal to 0.0086, and our alpha was 1%. And so we can see that 0.0086 is smaller than 0.01, and so therefore the p-value is somewhere in here. And this means that if I randomly selected another sample of state and traditional quarters independently, that the probability I would have the same results is smaller than making that type 1 error. And so that means that there is enough evidence for change, and then we would reject the null, right? We wouldn't keep status quo. So we would reject the null. Well, if we reject the null, let's go back up a little. That means we do not keep the null and we accept the alternative. And the alternative was the claim. So is there enough evidence to support the claim? So don't forget that as far as mathematically, we think of mathematically we reject the null or not. But in our interpretation and conversation, we talk about the claim. All right, so let's write a nice little sentence regarding the awesome quarters that we just tested about. So there is enough evidence to support the claim that state quarters, I should say that the mean, or I should say the average weight of state quarters is more than traditional. Okay, and so what you just have supported is the fact that state quarters may use more metal than the traditional quarters did. And since because our quarters came from populations that were approximately normal and samples were taken that were independent, we can say that there's enough evidence to support the fact that the state quarters will weigh more, and that's probably because they're probably using a little more metal.